In the previous video, we saw that there are three ways to prove two triangles similar. Angle-angle, side-side-side, or side-angle-side. So we're going to look at some examples, try to determine if the triangles are similar or not, and in the last two cases, use that information to find some missing side lengths. Okay, in our first picture here, this is the easiest situation. If two triangles have two pairs of congruent angles, they are similar by the angle-angle similarity postulate. So these guys are similar. They have two pairs of congruent angles. Angle A is congruent to angle E, and angle B is congruent to angle D. So we can write triangle ABC is similar to, and we just have to match up the corresponding parts, so angles are easy. Angle A is congruent to angle E, so I'll start the second guy off with E. Angle B is congruent to angle D, so that will come next, so this is EDF. And our reason is the angle-angle similarity postulate. Okay, in this case, we see that our two triangles have no angle information at all marked on them. So angle-angle is not a possibility, side-angle-side is not a possibility. Our only chance is these guys may be similar by side-side-side. For that to be true, all three ratios of corresponding sides have to be equal. Now, you might wonder, how do you determine what corresponds? And it's really pretty easy. You're going to take the smallest side of triangle ABC, which is the 5, and divide it by the smallest side of triangle DEF, which is the 15. 5 over 15 reduces to 1 over 3. Now take the middle size side of ABC, which is the 6, divide it by the middle size side of triangle DEF, which is the 18. 6 divided by 18 reduces to 1 over 3. Now we'll take the remaining sides, the largest sides, the 7 and the 21, and divide them. 7 over 21 also reduces to 1 over 3. So we can say that triangle ABC is similar to triangle. Now when I named ABC, I went across the short side and then the middle side when I said the letters ABC in that order. So if I want to go across the short side and then across the middle side, I would have to name our second triangle, triangle FED. Our reason is side-side-side similarity postulate. You might note that the scale factor here is 1 to 3. In this example, I only have one pair of angles, so it can't possibly be angle-angle for my reason. I don't have three sides, so it can't be side-side-side. My only chance is for side-angle-side. Now, side-angle-side requires that the sides, and let's look at triangle ABC first. I'm going to use the sides that are 6 and 9 because that's where I've got my length information. Now, the side that is length 6 is AB, and the side that is length 9 is BC. Notice that those two sides form or include angle B. That's a requirement to use side-angle-side. In my second triangle, the same thing is true. The two sides I'm using, the 8 and the 12, they form the angle that we're using, or they include it. So this is a possible side-angle-side. Now, if the angles had been marked elsewhere, side-angle-side would not be possible to even try. Now, for side-angle-side to work, it'll be a lot like side-side-side. We're going to take the smaller of the two sides and divide them. So I'm going to take 6 divided by 8, and when I reduce that, I get 3 over 4. Now, I'm going to take the bigger sides, the 9 and the 12. When I divide them, it's also 3 over 4. Since the ratios of the corresponding sides are equal, and the included angles. It's important that they were the included angles are congruent. The two triangles are congruent by side, angle, side. So we will write triangle ABC is similar to triangle DEF, and our reason will be the side, angle, side similarity postulate. In this example, we're going to try to see if the triangles are similar and then use that information, if they are similar, to find x and y. Well, I've got plenty of side information, but I don't have, if I knew what y was, I could attempt to use side, angle, side. But since I don't, my best and easiest choice is angle, angle. We have the angles already marked congruent, and if we then notice that we've got vertical angles that are congruent, the triangles are similar by angle, angle. That means we can form ratios of corresponding sides. Now the sides that correspond will be the sides that are between the same sets of angles. For instance, 10 over 12 would be a pair of corresponding sides because they are between the angles with 1 and 2 marks on them. Okay, the x and the 6 are corresponding sides because they are between the angles that have 2 marks and no marks. Finally, the 8 and the y are in correspondence because they are between the 1 mark angles and the no mark angles. Okay, so I can use this ratio 10 to 12, or I could even reduce that and say 5 over 6 to find the values of x and y. Notice when I did the 10 over 12, I worked from the left side triangle to the right side triangle. It was important that I did that on the other ratios as well. Okay, so to solve for x, 5 over 6 equals x over 6. Well, that's a pretty easy one. If 5 over 6 equals x over 6, we could cross multiply, but it's just plain old x equals 5. Okay, on our next one, we've got 5 over 6 equals 8 over y. Well, when I cross multiply here, I will have that 5y equals 48. So if we divide then, y will be 48 over 5. Let's take a look at one more example. This time, the two triangles are inside of each other. Well, that's a little bit different. We've got some parallel lines given, though. Notice that since the lines are parallel, corresponding angles will be congruent. So, the pair of angles I've just marked are corresponding, and they're congruent. And this pair of angles corresponding and congruent. And we might note that the little triangle on the inside and the big triangle on the outside actually share that third angle at the top. So the two triangles are indeed similar by angle, angle. To see what ratio to set up, let's take a look at the little triangle, which has sides of 2 and 4. I'll transfer the angle marks back. And let's take a look at the big triangle on the outside. It's got the 1 mark angle, the 2 mark angle, and the 3 mark angle also. Its bottom, well, or left side in this case, is x. Now, the missing side here is actually, in this case, it's the 2 plus the 4. So what I'm going to transfer over here is 2 plus 4, which is 6. That doesn't show up very well, so let me rewrite that in red. That's 6. Now we'll form ratios of corresponding sides. The 2 would correspond to the 6. They're between the 1 and 3 marked angles. 2 over 6 equals, and the 4 would correspond to x because they're between the 1 and 2 mark angles. 4 over x. So now we've got 2x is 24, and x equals 12. So it would appear here that you should have all the artillery you need to solve any problem in section 6.3.